Hi, I'm going to be discussing two-factor ANOVA and how to apply it to engineering. So what is two-factor ANOVA? A two-factor ANOVA is a statistical analysis tool that is designed to compare mean differences between groups of data that are cut into two separate independent variables. In other words, we want to determine what impacts the variation of the data based on the two independent variables. Here are the steps to calculate two-factor ANOVA. 1. Determine what factors you will be testing. Make sure these factors are independent of each other. 2. Create a hypothesis. 3. Calculate all averages and variances. We want to do this for each cell combination and calculate total averages. 4. Calculate sum of squares, degrees of freedom, mean square, f-values, p-values, and f-critical values. And number 5. Analyze the data and determine your hypothesis. From there, we will either reject or fail to reject the null hypothesis. Let's create an example that can be applied to the world of engineering. I have collected this data from a report that studies bridge failures in the United States. This data shows the number of bridge failures for each facility type and the material used. We are going to use this data to create two-factor ANOVA. The two factors that we will consider are facility type and material type. Our hypotheses state that the factors will have no significant effect on bridge failures, and our alternative hypotheses state that they will have a significant effect on bridge failures. Given the data, we have our two factors, material and facility, and from here we are going to calculate the averages in the row direction and in the column direction, and then we're going to calculate total averages for each cell combination. So we found our averages. Now we're going to calculate our variance. And using Excel, we will use the data analysis tool to use two-factor ANOVA without replication to find the sum of squares, degrees of freedom, mean square, f-values, p-values, and f-critical values. We will now use this to analyze our test. We will analyze our data with our f and f-critical values. If the f-value is greater than the f-critical value, we will reject the null. If the f-value is less than the f-critical value, we will fail to reject the null. Facility type has an f-value greater than the f-critical value, so we will reject the null hypothesis. Material type has a f-value that is less than the f-critical value, so we will fail to reject the null hypothesis. Since we rejected the null for the facility type, we can assume that it has effect on bridge failures in the United States. While material type, we failed to reject the null, we can assume that it has very little to no significant effect on bridge failures in the United States. That is our conclusion, and thank you for watching.